Hello everybody, my name is Kevin and today I'll be demonstrating my final year undergraduate project. My final year project was to build a distributed collaborative workspace with a private Ethereum proof of authority blockchain backend. In this demonstration, I'll go into the basics of distributed ledger technology and the applications of blockchains beyond just cryptocurrency. In this demonstration, I'll be running two instances of the dApp, each acting as a separate user. I'll also be explaining some of the functionality of this dApp, as well as some of the interesting things that is happening within the back end of the decentralized app. First of all, I make sure that the users are all connected to the blockchain network using the browser extension MetaMask. Here, I name my private blockchain network Workspace. MetaMask is used to connect to any blockchain network, as well as confirming or rejecting any transaction that is conducted within the dApp. Here we can see user 2 is welcoming the team to the project by creating a post in the activity feed. As you can see, a confirmation to MetaMask is needed to conduct this transaction. The activity feed is used within this decentralized app by the user to monitor and keep track of what people are doing within the project. To understand what is happening there, I have to briefly explain the concept of a smart contract. A smart contract is a set of computer protocols used to digitally facilitate, verify, and enforce the performance of a contract. In layman terms, a smart contract is used to facilitate the exchange of digital assets, and the smart contract permits credible transactions without a third party validating it. Bitcoin, which was the earliest popular blockchain implementation, facilitates money transaction in the decentralized method and removing the need of third parties like governments or banks. A user has an address. To send bitcoins to that user, one will simply just have to send the bitcoin to that user's address. On Ethereum, decentralized applications also have addresses, and these are referred to as smart contracts when they are stored on-chain. To use a decentralized application, a user would simply have to send transactions directly to the address of the smart contract, similarly to how to send bitcoins on this Bitcoin network. These transactions will include the functions that a user wants to call on the contract, and the user must have enough Ether, the cryptocurrency for Ethereum, to cover the cost of running the computation that the user is asking for. This is called gas. The contract will receive the transactions and use the gas paid to compute the functions called. The results will be returned to the user and the state of the blockchain is changed. So, looking back into the project, we go to user 1 looking at the newsfeed, waiting for an update. He sees the welcome message from user 2 and shows his appreciation for being added. He then asks for a Gantt chart and that he will upload the report for this project. Once again, a MetaMask confirmation is needed to confirm the transaction for creating a post. He then navigates to the home page where he will upload the report into the workspace. A drop area is used here for the user to input the files from his home computer. Here I'll be talking very briefly about how the file storage system is done within this project. This project uses a system called the Interplanetary File Storage System. This system stores files in a decentralized fashion by hosting different parts of the documents within different nodes in the network. A hash is then assigned to the document in the IPFS network, and the hash is later used to reassemble the file again. This diagram shows the flow of uploading a document within the application. The document is first uploaded to the application via the drop area. The application will then use the document and upload it to IPFS, and storing the returning hash on the net blockchain. This is done to reduce the amount of space used within the network. For example, a 5-paged work process document will typically have a size of roughly 500 kilobytes, whereas a hash from that document on IPFS will only have a size of about 70 bytes. Another reason not to store large files on the blockchain is the problem of access latency. This means how long it takes a user to upload and download data on the network. The main Ethereum network has tens of thousands of nodes, and the amount of latencies in uploading data grows with the amount of nodes within the network. So it is beneficial to reduce the amount of data kept on chain. Back to the demonstration. 2 confirmation is needed by MetaMask to confirm the transaction for uploading a document, and 1 for creating a post to alert other users that a new file has been uploaded. Clicking the Go to Document button, it will redirect you to a URL of the reassembled document hosted by IPFS. At this point, I want to point out that the posts on the newsfeed and the document hashes are both stored on the blockchain network. It does not cost any gas to read the value of the posts or the hashes of a document. As you can see, no MetaMask confirmation is needed to load the document or look at the newsfeed. The only time that MetaMask will ask for a confirmation is when the user wants to change the state of a blockchain network. For example, adding a post to the newsfeed or uploading a new document. Here we see that an update is needed for the supply document. User 2 is notified that he needs to update the document on the newsfeed. He implements the changes and clicks on the Update Document button on the relevant document. A drop area then appears for him to drop the new version in. The new version is then uploaded to IPFS, and the new hash will replace the old one on the blockchain. So that was a brief demonstration of my final year project on blockchains and the distributed ledger technology. Blockchain technology has much more impact on today's internet than just the applications of cryptocurrencies. It gives access to a decentralized web model and solves the problem of trust on the internet today. My name is Kevin, and if you've got any question, please don't hesitate to contact me at yt00233@surrey.ac.uk.